Hey friends, we are still in chapter 4, or we're now entering chapter 4. We're going to do something a little bit different. We're going to actually look at two sections at one time, especially since in class we already discussed the distributive property. So the first thing we're going to take a look at is some vocabulary, and I have to be honest with you, we've got quite a bit of vocabulary, a little bit more than usual, and a number of examples, I'd say 6. So leave some space, make sure you're writing neatly, and make sure you are paying close attention to what these words mean so we can figure out how to use them in our discussion of math. So the first thing we've got is equivalent expressions, and clearly they're expressions that are equal or that have the same value. And so as we look at this term, we see that this property, called the distributive property, gives us two expressions that are equivalent. And we talked a little bit about this in class. I want to just quickly do a quick demonstration. If I were trying to multiply 6 times 10, clearly I know that the answer is 60. But an equivalent way of looking at that is to look at 10 as the sum of two numbers. Let's say 3 and 7. So I can actually take 6 times 3 plus 7, 6 times the quantity of 3 plus 7, and figure that out in parts. I can take 6 times 3 and then add to that 6 times 7. If you do the math, you'll see that when I add those two values up, I indeed get 60. So here we see the distributive property is a property that gives us equivalent expressions. The next few terms that we're going to look at, or the next few vocabulary words, are going to be really necessary for us to move forward in understanding certain things in algebra. So one thing that we're going to talk about is the idea of a term. A term is each part of an algebraic expression. So for example, if I have 3x plus 2y plus 5 over 7x minus, 9. What I have here would be an algebraic expression that is displaying 4 terms. Notice I've got 4 pieces, in a sense, that are being separated by addition and subtraction. So an algebraic expression, or terms are part of an algebraic expression. The next concept we'll talk about, let me change the color on that. The next topic that we'll talk about is, as we see here, we've got the idea of a coefficient. A coefficient refers to the number that's being multiplied by a variable. So if we look at the example we just had, we had 3x plus 2y plus 5 over 7x minus 9. The coefficients that we have here, the numbers that are considered coefficients, I'm going to circle in purple, would be 3, 2, 7 is a coefficient of x, and those are the only, quote, coefficients we have here. So coefficients are numbers that are being multiplied with a variable, or numbers that are next to a variable, right next to a variable. That refers to multiplication there. Like terms are terms that are alike. And I think you guys probably figured that out just by the terminology. I'm going to take that away so we can take a look at the concept of like terms. If I have a situation, let me get back to my nice red pen. If I have a situation where I have, let's say, 3x plus 2y plus x, like terms are terms that are alike. So the 3x and the x are like terms. Y is not a like term here. The 2y is not a like term. We can also consider like terms when we think about an expression that contains this next vocabulary word, constants. A constant is a number without a variable. So if we look at the problem that I'm going to put down here, or the expression that I'm going to put here, I could have 4x minus 3y plus 7 minus x plus 2y. So here's this expression. How many terms does it have as I have it listed here? Do you know? Do you know? Do you know? Hopefully you realize that it has 5 terms, and a couple of these terms are alike. So I can circle 4x and this, I'm going to call it a negative 1x term. We'll talk about that later. I can circle these two terms, they're alike. I can put an underline under my y terms because they're alike. And then here I have a constant term that's not like anything else. But if I had another constant term, I can see that indeed we'd have several groups of like terms. And finally, this last vocabulary term, simplest form. Simplest form of a algebraic expression is one where there are no like terms. So what you would do in a case to make the simplest form is join your like terms together, and we'll discuss that shortly. Example 1, we're going to evaluate numerical expressions. Here we're going to use the distributive property to write each expression as an equivalent expression. Then we're going to evaluate the expression. So what we're going to do is capitalize on the concept that we talked about when we defined the distributive property. We're going to write this as 5 times 12 plus the quantity of 5 times 4. Since 5 times 12 is 60 and 5 times 4 is 20, when I simplify that and join some things together, I get the value of 80. So 5 times the quantity of 12 plus 4 is 80. If we do this, notice that the 8 is hiding on the other side, but still, since there's no symbol between 8 and the parenthesis, it means that we're going to multiply. So we'll multiply 8 by each term. I've got, not 30, sorry about that, friends. I've got 20 times 8 minus 3 times 8. And so I end up with 160 minus 24. Then I get 136 as my answer. Notice that the term that we're multiplying through the particular expression could be on either side. We can also use the distributive property to simplify algebraic expressions. As you notice here, we can call this part A and this part B. We've got two different algebraic expressions, and we're going to use the distributive property to simplify. So simply put, we're going to multiply 4 times each of the terms inside of the parentheses, and so I end up with 4x plus 4 times 5. And the simplest way to write this is 4x plus 20. Following along, even though the 6 is on the right side, there's no sign in between the two, so that means that there is multiplication here. There's no sign between the 6 and the parenthesis. So what I'm going to do is multiply 6 times y plus 6 times 10, and my final answer is 6y plus 60. Here we're going to again work with algebraic expressions and simplifying them, but now we have a negative sign here. We have a minus sign, and things are really pretty much the same. What I want you to realize, though, as I multiply the 3 times the m and the 3 times the 4, you can kind of consider that for a negative 4 or a minus 4, because watch this. I get 3 times m, and then I'm going to get a negative 3 times 4, because if I'm multiplying this positive number times a negative number, I get a negative. So my ultimate answer is 3m minus 12. Over here, I have this negative 9 that I'm going to be distributing throughout this expression, and I have to pay close attention to the sign. So if I have a negative 9 times that positive n, my answer is going to be, well, let me write it like this, negative 9n minus 9 times a negative 7. That seems like gobbledygook, but here's the take home here. Negative 9 times n is going to be a negative 9n. And then a negative 9 times this negative 7 is going to end up with a positive 63. All right. So you do want to pay close attention to your signs. And indeed, when I see a minus sign, sometimes I really just consider it negative, the next number that's coming up in that expression. And this is something I know you guys already know how to do, but we're going to be looking at identifying like terms. So here we have a couple of expressions, and what I want to do is identify like terms by, let's say, writing a symbol or making a symbol around each term that is alike. So here I've got 3x. Are there any other x terms in this expression? Yes. 4x, and that's all. We've just identified like terms. So like terms are 3x and 4x. 4y is kind of alone and does not have a partner in crime. If we look at part B, let's identify the like terms here. So 5x is just like 7x because they both have x terms. They both have x as their variable. And I'm going to box out 3 and 4. These are constant terms, but they are like as well. So we found all pairs of like terms here. So here in this example, example 5, we're going to consider really breaking apart an expression and considering what things we have. So I'm going to make a little bit of a chart. So here's a little chart to organize our information. So as I look at this expression, I want to identify like terms. And so there's only one pair of like terms, 6x and x. Those are the only two like terms that are together there. 2y is not like anything else, nor is the negative 5. The next category is coefficients. We want to list those. So what are the coefficients? Remember, coefficients hang out next to a variable. I might surprise you with this. We have 3 coefficients. We've got 6, we have negative 2, and believe it or not, I think you probably figured it out, we've got 1 next to that x. Because there's 1x there, we don't really put a 1, but we should know that 1 is a coefficient of x. So we have 3 coefficients. And constants, I think you guys figured out, we only have 1, and I'm going to call that a minus 5. You could put 5 and say 5 is being subtracted, but now I want, as we work through these problems, for us to start seeing the operation sign in front of a term as part of the term sign. So in a way, I could say, if I go back to this expression, I've got a positive 6x, in a sense a negative 2y, a positive x here, and a negative 5. In this example, our final example, we're going to be simplifying an algebraic expression. And so what that means, if you remember, to make it simple, is to join like terms together. Remember, when you have an algebraic expression in its simplest form, you have an algebraic expression with no like terms. So if we look at part A over here, I'm going to join my like terms together. I've got a positive 4x and a positive 2x. Together, that's a positive 6x plus 6. And I've written this as simply as possible, so I'm done. In this one part B, we notice that we've got these n terms are the same, and then the constant terms are the same. So I've got 2 groupings that I'm going to do here. I'm going to take that off so I can see a little bit better. Let me do a little squiggly underneath. That's just like the other ones. All right, let me do wild dots underneath. Perfect. All right, so if I join some like terms together, I've got 5n and a negative 1n. So if I had 5 n's and I take away 1 n, I'm left with 4 n's. So that's what happened when I brought these guys together. And then over here, let me use a different color for clarity. I'm going to take my constant terms, which is a positive 2 and a negative 6. When I bring 2 plus a negative 6, I get a negative 4. And that's where these guys came from. That's how they got there. And then so this is as simple as possible. There are no other like terms, so I cannot join anything else. This problem here may look a bit challenging because I've got 6y minus 3 times the quantity of x minus 2y. Here's my advice. Whenever you want to simplify, you want to get rid of the parentheses. The only way to get rid of parentheses here is to multiply by that coefficient on the outside, that 3, that minus 3. So we're going to multiply throughout by a minus 3. I want you to hold on to this because this is going to rock your world. Maybe not, but watch. So I've got 6y. I'm going to take a negative 3 and multiply it by x. What do I get? A negative 3x. I'm going to take this same negative 3 and I'm going to multiply it by a negative 2y. Wait for it. Yes, you do get a positive 6y. And so now that I've gotten rid of the parentheses by using my distributive property, I need to join my like terms together. What are my like terms? I've got a y term here and a y term here, and sadly, this 3x term is alone. So when I join my like terms together, I get 12y. And then this guy comes down here, and he's just along for the ride. Can't do much with him. He's a part of our solution, 12y minus 3x. All right, guys, thanks for coming along with me on this ride. We have an assignment here, actually 2 assignments. You don't have to do them all in one night, but all of the lesson and work that we just did will provide you with all the information you need to complete the following lessons. If you have any questions, let me know. Let's talk in class, and I look forward to seeing you soon.